This is part 9 of 8086 arithmetic instruction set. We will see MUL, that is unsigned multiply operation. So it multiplies an unsigned byte or word operand which is specified as the source operand with the contents of AX. So note here that AX is the implicit destination. So in the instruction format only the source is specified and the other operand will be taken from AX, or it is expected to be stored in AX. So let's see what are the various types of multiplications possible. So you can put a byte over here in source. Then what it means when you give MUL is the AL part of AX is taken and it is multiplied with your source. Okay, so when you specify a byte as source, not the entire contents of AX is taken, only the AL part of AX is taken. Suppose you are specifying a word source, that means the operand over here is a 16-bit word or entire register content. Then the entire contents of AX will be taken up and used for multiplication. Then one thing to note here is your source can't be an immediate operand. Okay, so source should always be a register or a memory operand. So we saw about the thing before issuing multiplication instruction, right? Or what is the setup for the multiplication instruction. Now let's see what happens with the result, or what are the variants in which a result may appear. So suppose if you are using a byte source, right? So if you are using a byte source, what happens? Multiplication with AL will happen. So the result will span over entire AX. Okay, so that's the main thing that you have to note, as we have seen in Booth's algorithm, right? In Booth's algorithm, we have seen that when you take a byte operands for multiplications, right, it will be, the result will be 16 bits. So same case here, when your source is byte and your destination is AL, the result will be stored in entire AX. Then again, suppose your source is a word operand, right? Then what happens? The destination will be the entire contents of AX. Now we need a double word as the result, or a space of double word is required to store the result. So that is taken up by combining DX. So the result will be spanning across DX AX with the higher order bits of the result in DX and the lower order bits of the result in AX. Then regarding the multiplication instruction, it will affect the flags register in this way. That means if the higher order bits of the product is 0, then CF and OF, that is the carry flag and overflow flags, will be cleared. Okay, so these are some examples of the multiplication instruction formats. So suppose your source is in BH, which means it's a byte source. Then multiplication proceeds like this. Your source will be multiplied with contents of AL and your result will be spanning across entire X. Then suppose that your source is in CX register, or it takes up 16 bits. So the destination will be the entire AX, right, and the result will be spanning across DXAX. And suppose your operand is a memory operand and it is indirect at rest. Okay, and suppose that the memory operand is occupying entire word size. Okay, we are taking an entire word sized memory operand. So it means that the implicit destination or the other operand will be the entire AX content. So it will be taken, and now we have a double word situation. So the result will be spanning across DXX. So this is all about multiplication operation. Now let's see unsigned division. So in case of unsigned division, DIV, right? So this is the opcode and this is the format. So the division happens like this. The dividend will be in the accumulator and the divisor you are specifying as part of the instruction. Okay, so divisor will be the source, dividend will be in the accumulator. So your dividend, unsigned dividend in the accumulator will be divided with the divisor which you are specifying as part of source. And again, the source can't be an immediate operand. So let's see what are the various formats of operation of divide. Okay, DIV. So suppose your source is a byte. Okay, if your source is a byte, then dividend will be taken as the entire contents of AX register, and your remainder will be in AH and quotient will be in AL. So this is the main thing that you have to note. Even if the dividend spans the entire AX, right, and the divisor is just a byte, the quotient is in AL or in the lowermost byte of x, and remainder will be in the uppermost byte of x. Then suppose that your divisor or source is a word, or it is the size of an entire register, right? Then your dividend is supposed to span across dx x, right, with the uppermost bits of dividend in dx and lowermost bits of dividend in x. And after division, your remainder will be in dx and quotient will be in x. Then in case of division instruction, it doesn't affect any flags or the flags register, but the overflow condition whenever it happens. For instance, when you divide a dividend by 0, right, if your source is 0, it will definitely result in an overflow condition that is indicated using a divider error exception or a software exception.